We've looked at how to calculate pH. We can measure pH a variety of ways, with pH meter or with pH paper. A pH meter actually measures the conductance of those ions in solution, and it works better for us in the lab because it works on colored solutions. If you have something that has, say, copper ions in it, so you have a blue solution, you can still see what the pH is using a pH meter. pH paper is embedded with several different dyes or particular indicators, and these are materials that change color when there's excess hydrogen or hydroxide ions in solution. So pH paper works nicely in the lab for a quick and dirty, but the problem is it doesn't work really well in colored solutions. You really have to use a pH meter for that. We were introduced to doing titrations in Chem 101 or Chem 111, wherever you first learned to do them, and we used acid-base indicators. Indicators are the same kind of chemical compounds that change color when the hydrogen or hydroxide ion concentration changes in the vicinity. And we can use these to tell us when a titration is done. We're going to talk a lot more about titrating later in this chapter. But the pH meters work better for titrations too, but they cost more, and sometimes the ones we can afford with batteries keep turning themselves off, and that's a nuisance. So we use indicators because it's quick and dirty. But when we're talking about pH, it is most useful when there is a small amount of hydrogen ion in the solution. And if you think about this, if we talk about concentrated hydrochloric acid, concentrated HCl comes as a 16 molar solution. What would the pH of that be? Go ahead, calculate it. What's minus the log of 16? It's a negative number, right? And so we don't think of pH as going negative. So when you have something super concentrated, it's a negative number when we calculate it. We just say its pH is 0 because that's as far down as we go. So it's useful in dilute solutions of strong acids and bases, or it works really nicely with weak acids and weak bases where you have lower concentrations of the hydrogen ion or hydroxide ion in solution. So strong acids and bases, remember by definition, they are completely ionized. If I put hydrogen chloride gas in water and make hydrochloric acid, HCl is a strong acid. It breaks apart completely and makes hydrogen ions plus chloride ions. Sodium hydroxide is a readily soluble salt. It dissolves right away, and when it dissolves, it breaks apart into sodium ions and hydroxide ions. If we think about something like iron hydroxide, say iron 3 hydroxide, iron 3 hydroxide dissolves only a little bit. Mostly it sits on the bottom of the container. But if you could look in there with your molecule seeing eye, you would see in the beaker lots of solids sitting on the bottom, and then what did dissolve, you would see iron 3 ions and you would see hydroxide ions. So even though this strong base is not readily soluble, what does dissolve ionizes completely. So strong bases ionize completely even if they do not dissolve readily. Okay, let's look at a couple of quick problems. What's the hydrogen ion concentration in 0.2 molar HCl? So you ask yourself what's in the parentheses. Is this a strong acid or a weak acid? Self. What does your self say? HCl? Strong, right? So that means that if it's a strong acid, that it breaks apart completely. So the hydrogen ion concentration is the same as the acid concentration. And actually now, if I look in there, There is no HCl in a beaker or a bottle labeled HCl. There's only hydrogen ions and chloride ions. So the hydrogen ion concentration is the same as the acid. So I could find the pH from that. What is the hydroxide ion concentration in 0.35 molar calcium hydroxide? First of all, you have to ask yourself, what is it? It's a base. What kind of base? Weak or strong? Strong. And how do you know that? No. Because it contains hydroxide. That's the definition of a strong base. It contains hydroxide. There is a chart about solubility. Okay, so that's the next question. Does this dissolve readily? Yes or no? Yes. Calcium, barium, strontium, right? So, what's the hydroxide concentration? Just tell me. Do it in your head, quick and dirty. What is it? I couldn't hear. You got to say it loud when I got this thing on. It's not 0.35. Why? It's double that, 0.70, right? Because you get a 2-for-1 sale. So that's something to be mindful of. Look at the formula and figure out what is the concentration. Then we can use that information to find pH. Okay, our time is up. We're going to stop here.